Good morning or good afternoon, depending on the time when watching this. Um, my name is Osman, and today I will introduce you to QuadConnect, the digital heartbeat of campus life. Summer and I wanted to show how we are solving a critical problem for students by building a unified social hub with modern technology. Let's start with the problem. Campus life today is fragmented. Students are forced to juggle email for events, separate chat apps for clubs, and social media for connections. This makes it hard to find a study partner tonight or learn about an event happening in an hour. There's no central hub. Our solution is QuadConnect. It brings everything, events, chat, community posts into one place. It's real time and it's built specifically for student needs, creating a unified digital campus experience. To to build this reliable experience, we chose a powerful and modern tech stack. The front end is built with Flutter, allowing us to create a single high performance app for both iOS and Android. Everything on the back end is powered by Google's Firebase platform. It provides our authentication, real time database, and cloud storage out of the box. To manage all the app's data and state reactively, we use RiverPod, and for smooth navigation between all our features, we implemented GoRouter. So, what does the student actually experience? QuadConnect offers 5 core features. First, secure authentication and profiles. Second, a dynamic news feed that updates in real time. Third, direct messaging with typing indicators. Fourth, a complete campus events hub for discovery and RSVP. And fifth, built-in social engagement through likes and comments. Together, these features turn the app from a utility into a vibrant community space. Diving into the architecture, it all starts with secure access. We use Firebase authentication to handle logins. It manages secure token-based sessions automatically. The flow is seamless. A student signs up, their credentials are validated securely by Google servers, their profile is created in our database, and the app maintains their session. This security and ease is the foundation for trust in the platform. All user data needs a home. That's our cloud Firestore database, organized into clear collections. We have a users collection for profiles, a post collections for the feed, an events collection, and a conversations collection for messages. This structured architecture is what allows every piece of data to sync and update in real time across the entire app. This brings us to the most engaging part, real-time features. Because of Firestore, everything is live. When someone makes a post, it instantly appears on their friends' feeds. When they send a message, it's delivered immediately. You see typing indicators and like counts update live. These live streams are what makes the campus feel connected and active, like a true digital heartbeat. To build and maintain all this complexity, we organize our code with a clean, scalable architecture. We use a feature first structure with separate modules for authentication, the feed, messaging, and events. All shared utilities live in a core module. This separation of concerns means our code is clean, easy to test, and ready for future features. Finally, the engine room. This clean's architecture is powered by dedicated servers. This clean architecture is powered by dedicated services. Our authentication service handles all login logic. Our Firestore service manages every database operation. Our message service orchestrates real-time chats. These services are the workhorse that translate our clean design into the fast, reliable features students use every day.
Hello, my name is Summer Hope, and I will be going over slides 10 through 17 for our QuadConnect presentation, as well as doing a demo. Now, first, I want to start with our dynamic feed system. One of the features of QuadConnect is that we want users to be able to post images and post about anything that they want, and we want other students to be able to see it. So basically, new posts from friends appear instantly at the top of the feed, creating a lively and active community feel. So we want this to feel like any other social media app, where you can see what your friends have been up to. You could read their thoughts on everything. And to do that, we had to implement a few different things. So our first one is real-time stream. So direct subscriptions to Firestore Post collection provides instant data synchronization across clients. So this allows us to be able to see what other people post right when they post it. Optimize media. So this uses a technique called aggressive image catching. It's a strategy with placeholders and error widgets to minimize bandwidth usage. Next is pagination logic, and that is a cursor-based pagination fetching data in chunks of 10 items to reduce initial load time and database cost. And then next we have client filtering, so local state management to filter posts by category or search items without re-querying the entire database. So basically, we want the user to only be able to see posts, like specific posts that they might be looking for. All right, next is direct messaging. So we want students or just any QuadConnect user to be able to DM other students. So first is search and connect. So students can do that by searching for their peers through email. The system automatically provisions a new chat or retrieves existing history. Real-time delivery, instant message transmission with visual confirmation creates a responsive modern chat experience. And then smart indicators. Live typing indicators and unread message badges keep users engaged and aware of conversation status. So this is kind of just like, I don't know how you would DM somebody on Instagram. Like if you're already following them, then you could just search their name and then you could just hit the message button and then you could send them a DM. And a lot of times, if they're responding back to you and then they're in the middle of typing, then you might see those dots that pop up, indicating that they're typing and are probably about to send you a message. And to implement those things, we use Firestore subcollections. So the subcollections are scalable data architecture storing message documents within individual conversation documents to manage large data sets, real-time listeners, persistent stream subscriptions on active threads ensure zero latency updates when new messages arrive. So basically, we want our users to be able uh, to send messages and that person gets those messages right when they're sent. Efficient querying, optimize compound queries, sort messages by timestamp, and filter by participants without performance degradation. All right, our next thing. All right, so the next part of QuadConnect app is the campus event hub. So the idea behind this is that users can browse campus happenings filtered by categories such as social, study, sports, and we have a bunch of other categories too, or date. Uh, if a student wants to participate in that event, then they can RSVP. So all they have to do is tap the RSVP button on that event, and they get a instant confirmation that they're going to be attending the event. Um, Creation Hub. intuitive interface for organizers to publish event details, set limits, and upload covers. Attendee tracking, view which friends are attending an event before committing to join. So like if you could see like what friends are attending the event, and you could also see how many people are attending as well. So the things that we use to implement that, so we have the events collection. Um, so this uh, So this stores stuff like the title, date, location, capacity category, and organizer ID associated with the event, attendee subcollection, scalable subcollection tracking individual RSVPs to avoid document size limits. Transactional RSVPs automatically decrements capacity to prevent overbooking during concurrent user actions. Real-time availability. Live listeners update the spot's remaining counter instantly across all client devices. All right, so these are kind of a few of the challenges that we face when putting together this app. So the first is real-time feed performance. So basically trying to like render image post, um, data pagination, handling queries for potentially thousands of posts and eventually uh, handling queries for potentially thousands of posts and events efficiently. Notification state, keeping unread message count synchronized across different app tabs instantly. Email lookup and search, providing consistent user search results regardless of input casing. And threaded comments, displays nested replies visually while maintaining a flat database structure. All right, next, performance optimizations. So these are a few things that we did in order to optimize the performance. Image catching, implemented intelligent caching for network images to reduce bandwidth and enable instant loading on revisit. Lazy loading, data is fetched incrementally at the user scrolls as the user scrolls, preventing memory bloat and reducing initial startup time. Stream management, efficient Firestore listener lifecycle management ensures zero memory leaks and reduced battery consumption. Client-side filtering, performing light filtering on the device reduces the number of read operations sent to the database. Optimize queries, utilize limit method and compounded indices ensures queries remain fast regardless of total data set size. All right, and now I'm going to do the demo.